So Cosmos DB is really, I guess, born in Azure. So it's pretty kind of easy to grow with the Azure and doesn't have to need all those extra, I guess, configuration or anything like that. As I said before, you want your data close to your users. So that means that you are going to be able to actually get closer to your users with this new 17 new data centers. But other thing like I want to actually say, whenever we talk about the databases, Cosmos DB or SQL Server, well, the users are not going to come from like wherever they live, right? They are going to come from the web application. So you want to actually be sure that the web application, which users are going to actually come and retrieve data, you want to be sure that the web application and the data server is in the same region. So the latency between two are the lowest. So you want to be sure that you do that. All right, so let's go back to Cosmos DB and Cosmos DB's history. In 2010, Microsoft actually started this project as just like for internally, and they call it Project Florence. The main reason they needed that is, they had SQL Server for relational database, but they did not have any kind of NoSQL non-relational database. So they started in 2010. They wanted to use that in their big products like Xbox, Office, Skype, which users are all over the world and they are sharing all kind of data. And it was pretty clear that SQL Server was not going to cut that. So they started with the NoSQL database in 2010. In 2015, they had a stable product and they were actually using internally. They say, well, why don't we share that with public and make money, right? So they did that in 2015 and they called that product name Azure Document DB. That was a NoSQL database, and the developers can actually save the data as JSON in cloud, and they can retrieve the data back with a language very close to T-SQL. So people like it, and it was growing. Cosmos DB team did not stop working on it. They will continue adding more features in 2017. A big change comes up. They change the name from Document DB to Cosmos DB, and they add the global distribution and multi-model, which you can actually call and get the data with different languages rather than T-SQL. After that, well, unfortunately, we end up with the COVID, right, in 2020, but we start to see, more functions actually came for Cosmos DB. Now we have the serverless. You can actually auto-scale, so which means that if you don't know how much, power you need from the Cosmos DB can guess it for you, and it can go up and down, scale up and scale down automatically for you. Right now in 2021, there's a new feature coming up I'm very excited about, which is the hierarchical partition keys. So it's pretty difficult to pick partition key for the new projects. So by this new hierarchical partition keys, you can actually pick more than one potential partition key, and it will actually make things much flexible. All right, so that's the history. And the first thing you kind of need to know, I'm sure that you heard that many times from Cosmos DB if you were in any other events, is the partitioning. Partitioning is very important. And there are two partitions that you kind of need to know. The first one is the physical partition, which you don't have absolutely no right to change anything on it, but you kind of need to know it is there, and that's how it works. So physical partitions are really, whenever you create the Cosmos DB service and you create your first database, the Cosmos DB is actually giving you one empty container ship. Literally just a container ship. And we can just call that as a physical partition. There are two numbers you need to know by heart if you're using the Cosmos DB about the physical partitions. The first one is the 50 gig. That is the capacity. That's how much you can load data in this container ship. If you are going to have more than 50, then that means you are going to end up with another container ship, so you can actually save more data. So you kind of need to watch that because, well, in a little bit, I'm going to actually explain that why you have to watch that. Second one is the horsepower. Well, you have the ship, you kind of need some kind of resource to make that work. And that's how you set up the Cosmos DB. That's actually the cost at the end, really. So this can give you the maximum 10,000 request units. In other words, let's say we have a web application and we maybe have 20 gig data. But for whatever reason, maybe the next day is a Black Friday and we don't want our web application to go down because we are going to have a lot of users. Then we say, you know what, that's maybe your horsepower is, or the request unit is 6,000. So you know what, for tomorrow, I'm going to make that 15,000. As soon as you make that 15,000, even you don't have 50 gig data, you're going to end up with a new physical partition. So you're going to have two. So those are the two numbers that you should know by heart, and you should always kind of check maybe monthly how much data you have and your request units, and you will know that how many physical partitions you have. If we go a little bit more deeper in the physical partitions, so if you, I guess, open and look at the engine of this ship, well, we have a replica set. So we have 4 copies of your database. The first one is the leader. Leader is responsible for updates, deletes, any kind of data change. It always goes to the leader. And leader actually pushes that all the followers. And this model is actually for only if you do not have global distribution. Now, this kind of tells you why Cosmos DB is very fast, because if you think about it, you have a web application. Potentially, your web application can hit 4 places to get the data, not only one, but it has 4. Which one is going to hit? That really is whole another talk, is about the consistency levels in Cosmos DB. But you can control that. So that's one of the main reasons Cosmos DB is very fast, because this is one physical partition. You have 4 copies. If you have 2 physical partitions, you have 8 copies, right? So it's going to grow pretty fast, and it's going to be available nicely for the web application or any other application you are going to use it for. Now, this model changes a little bit if you have global distribution. So as you can see, one of the followers actually turns into forwarder. So in this case, let's say we have our users here, and they're going to send some kind of data change. It's going to go to the leader. Leader is going to give it all the other followers and the forwarder. Then forwarder's job is going to actually take this change and push to other regions, other leaders. In that case, that's how, I guess, the data is going to get synced in the backend. So you don't need to worry about, I guess, if you have the same data in region 1 and region 2. So that's how Cosmos DB actually works in the backend. Now, usually, this is the place that I get the question about conflicts. So does conflicts happen? Well, conflicts happen in any databases. So things can happen. You might have an insert conflict, replace conflict, or delete conflict. So in other case, you have a user maybe in United States, and you have another one in Europe. They try to maybe update the same data or delete the same data, or maybe try to insert the same data. What do you do in that case? So when that happens, our referee comes from nowhere from there and says, well, we have a problem here. So for the conflicts, you have 2 options in Cosmos DB. If you don't change anything, that means that the last right wins. That's pretty simple, but that really doesn't apply to everybody, right? I wish the life was that simple. So if you maybe need to go and look at all the models, like all the JSON documents that are coming from, and try to figure out which one is you're going to trust and which one you're going to troll, then you're going to actually pick the custom. In custom option, what you really do is you create a store procedure, and you are going to put all the business logic in that store procedure, which is going to try to figure out which data to trust. And when a conflict happens, it's going to go in a queue. And Cosmos DB is going to take those conflicts one by one and run your store procedure, then try to resolve the problem for you. So that's how the conflicts, I guess, handle in Cosmos DB. Now, let's go back to physical partitions. As I said before, you should watch the physical partitions. You want to be sure that you know how many physical partitions you have, and if you have any kind of hot partitioning, which maybe one physical partition is really like high, the other one doesn't have that much data. So you want to be kind of sure where you are with all those. So to check that, you can actually go to the Cosmos DB's page. And under the monitoring here, you have the metrics. Just pick the metrics out there and click the storage. After the storage, you need to pick which database and which container you want to look at. And after you kind of fill those up, you are going to actually see all this graph and charts in the bottom. So what is important here for the physical partition is this part. And this one is telling us that we have 3 physical partitions. And each of them, if you actually click on it, I click on this one here, this is going to tell you if any of the, I guess, the partitions are, I guess, significantly higher than the others. So, and you can see this chart is kind of a little bit larger than this one. So you really want to see that, they are not going to be equal because, there's no way we're going to make them equal, but they want to be kind of close to each other. In that case, as you can see, the balance is not really that well. And we know that there's some kind of problem here. So when you click here, it's going to actually tell you which partition keys are having more data than others. So you want to really watch this. There's not that much you can do in here, but you want to be sure that if you are having issues, you want to know early as possible, because when this problem actually goes and gets out of control, it's not going to be easy to kind of fix. So it's always kind of good to watch if you are having any problems in this level with the physical partitions. Now, so physical partition, you couldn't do that much, but with the logical partition, you can. So if we talk about the logical partition, this is the place that you actually create a partition key. So really, partitioning in Cosmos DB is about organizing. So just like anything in life, if you organize, if you are, for example, if your garage is organized, it will be easy to kind of go and find what you are looking for, right? We don't really think that much about that when we are saving the data in databases. So in partition keys, we're really trying to organize your data. So first of all, it distributes all the requests. It distributes the storage, and it's intelligently route the queries for efficiency. So it's pretty important. You want to spend time and try to figure out a good partition key for your solution. That will save you a lot of money and headache for feature. So if we actually compare the SQL Server to Cosmos DB when it comes to the partitioning, usually what happens is, it might be different for you, but that's from my experience, is a developer goes and create the data models, and they go to production with it. So they give it to DBA, DBA checks everything and puts on the production. So usually what happens is maybe 6 months later, 7 months later, they go back to the DBA. They say that, everything was working fine, but we can see that things are kind of slowing down now. DBA goes and looks at it and says, well, you might need some indexes here, here, here. So you create the indexes, everything goes back to normal. Well, maybe 2-3 years later, you send your project manager again to DBA and say that, things are slowing down again. What's happening? Then DBA looks at the, the tables, the data, and they say that maybe he or she says that, well, maybe it's time for you to actually create some partitions. He or she creates the partitioning, and everything goes back to normal as long as you use the partition key. So usually that's how stuff happens in SQL Server. It's like another kind of way that if it doesn't, I guess, if it works, don't poke it, right? This is the same kind of idea. But in the Cosmos DB, it doesn't work like that at all. You actually have to create the partitioning in the beginning, not at the end. And always you have to actually create it without no data. So without giving a partition key, you cannot create any kind of tables or containers. So usually that is the place that many people make mistakes, and they don't really spend that much time to figure out which partition key they should use. Then, people say that, oh, Cosmos DB is expensive. Well, it will be expensive if you pick a wrong partition key for it, and if you don't use it in your queries. Other thing you need to kind of watch is what kind of application you are developing. Is it going to be a write-heavy application or is it going to be a read-heavy application? For write-heavy applications, you maybe don't care to know about the partition key later because what your concern is you are writing the data. Maybe if this is an IoT application, for example, you don't care about reading data. You care about you write the data as soon as possible. In that case, you want your partition key very unique. So you might want to create even like maybe like a dynamic partition key when you're writing it. That will make everything very fast. But if it's a read-heavy application, that means that whenever you are actually reading the data, you should know the partition key so you can put in the where clause on the filter. In that case, you want to be sure whatever partition key you are creating is gonna be, you're gonna know whenever you are actually try to retrieve the data. So those are the two things that you kind of really need to spend time and know, and don't feel like, if you spend this on maybe 1 week or something, it's okay because that's gonna save you a lot of money later. And it might be difficult because, as I say before, in the SQL Server, when we are trying to figure out the partitioning, usually it's the date, year, or something like that. But to make that decision, you already have this data, years of data, so you can make that decision easily. In Cosmos DB, you don't have any data, so you kind of really need to spend some time on it and figure out the right one. Now, if we put those together, we have the physical partition, which is the container ship. And logical partitions are really the containers. And the first thing you need to know about the logical partitions are each of those containers you have, there's a limit, which is the 20 gig. Hopefully you won't hit that limit because, well, Cosmos DB likes those containers small. The main reason for that is whenever you have like a new physical partition comes up later, we might want to maybe move some of those containers to the other ship so everything will be balanced. If you have one huge container out there, it might not be even worth it to change, move it from one place to the other place, and that will cause a lot of problems. For example, let's say we are creating an IoT application, and let's say it's going to be for a car. And maybe we are just going to read and write data about the car, about the driver, whatever. So there are many ways we can actually organize this data. So we can organize by the model of the car. We can organize by the color of the car. We can organize maybe year of the car. So there are many ways, right? And Cosmos DB really doesn't tell you this is the way you should do it. So let's think about it. If you're going to actually do partition key, maybe the year of the car, what's going to happen here is maybe this year you're going to have maybe 100,000 cars you're going to sell this year. Next year, people might love it, and you sell 1 million of the cars. Then you're going to have a problem because 1 million cars probably is not going to hit in one container that you're going to have a problem with the 20 gig. So that might not be a good kind of partition key for that. Also, whenever, let's say you pick the year, right? Even you pick the year and you try to write or read data, and you are using the year in your where clause, Cosmos DB still need to kind of go and open this big container, which has 100,000 cars in it, and still try to figure out which car you need to go and update or retrieve data from. That's still a lot of work. A lot of work equals money, right? So that will make things more expensive for you. If you will actually put one car in each container, it will be much easy to find this car, to write or read, and it will be much easier for Cosmos DB to move this car from one physical partition to other physical partition if it's needed. So Cosmos DB likes small partition, small containers in this case. The other thing that you need to know, you cannot repartition Cosmos DB container. So you better pick a right one, because if you're going to hit that 20 gig, or if you are close to that 20 gig, the best thing you can do is creating another table with the different partition key and move your data from here to the other one. You cannot repartition your current container. So that's another thing to know. All right, so when it comes to the IoT devices, we might have some issues because those devices usually do not have that much properties to, I guess, to create a partition key. For example, if it's a sensor, it may be sensing the, I don't know, the engine and how, I guess, the temperature or anything like that. All it really cares is maybe the temperature and maybe some kind of ID it has. It might have the current date, but that's it. How are you going to actually pick something, I guess, a unique partition key from that much data properties? It's not that easy. That's why we have synthetic keys. So here we have a bunch of IoT devices, as you can see. They're all over the place. And let's say they're all kind of sensors, sensing all kind of stuff about the car, right? So usually, I guess we will have the device ID. Device ID, I'm guessing it will be the sensor ID. I don't think it will be Knight Rider because not every sensor, I don't think you can program every sensor about the car's VIN. So it's going to be probably a sensor ID. And the other thing we are going to know probably is the year. So there's not really that much data. Other properties we are going to have here probably is about whatever that, is sensing. It can be temperature, it can be pressure, it can be, whatever it's trying to get value from. So in this case like that, what we can do is we can actually combine those together. And the other thing this actually came here. If you're going to pick the year, the problem is maybe this year you have 5 Knight Riders, but next year you might have maybe 100, 100,000, 1 million. So really picking the date, like what we do in SQL Server, is really not a good idea for Cosmos DB. So anyway, so if we are going to actually try to make this more unique, what we can do here is we can kind of combine these properties. So it's going to actually make the things a little bit more, I guess, unique. You can go this way, or if you really don't care about reading the data, all you care is the writing the data, what you can do here is you can combine the properties. Then at the end of it, you can randomly put a number out there. Let's say you pick from 0 to 200. So that's really going to be unique. This is going to be really fast to write. But if you're going to try to read that data later, there is no way you're going to be able to, I guess this partition key. So I guess if you care about only writing, this is perfect. But if you're reading, yeah, don't do this. Also, what else you can do if you are thinking about the reading? Well, you might be able to, hash some of those properties. So even you try to read later, you should be able to kind of find what this hash value is. So you can still, I guess, select the data by using the partition key. So that's another way you can do this. Now, let's go back to physical partition one more time. So we talk about the physical partition, which is the container ship. We talk about the logical partition, which are the data we load, which are the containers in this case. So let's say we have an application and our request unit is 9,000. Now, maybe we are going to upgrade this and say that we need more than 9,000. Let's say we are going to make this 12,000. As soon as we make this 12,000, as I said before, we pass the 10,000 request units. Well, we have a new physical partition, and that physical partition, which is the container ship, is going to need some resources to run, right? So you are not going to expect 12,000 here and 12,000 here. That's not going to work. So you still need to, I guess, pay for this physical partition in some way. That's why your request units is going to get divided by the number of physical partitions. So now you have 6,000 here and 6,000 here. If you have hot partitioning problem on this ship before you change this, and maybe you change this because you were getting 429 errors, which says that you don't have enough request unit to run the query, this might actually give you more problems because that means that you have a big container here, which may be taking 5,000-6,000 request units itself. Well, you try to fix the problem by adding request units, which means that you are paying more money on this. But guess what? Your actual request unit for this container ship is lower now. So this might end up giving you more problems than actually fixing the problem if you are having hot partitioning problems. If you actually balance everything well, this should not be a problem. But as I said before, if you have a hot partitioning problem, usually this is the time that people kind of usually learn that after they kind of increase the request units, they are having hot partitioning problem. And I guess the quick way to fix this, you kind of need to go back and maybe write 18,000 or 19,000, which means that you're going to actually pay much more than what you were paying before. And if you think that you're going to actually put this back 9,000 like before, but guess what? They are not going to combine. You end up with second physical partition, and it's going to be out there for, well, forever. Really. So they are never going to combine. So you have always this problem if you are having the hot partitioning problem. So this is kind of good to know. That's why you need to know request units 10,000 by heart. So you will kind of watch for problems like that before or after they happen. Let's actually look at storages. Now, when it comes to the storages, we have some options in Cosmos DB. So first of all, you create your application, you create your database. When you create the database, you are picking one of the APIs it has. And every time your application actually saves data, well, it's using one of those APIs and it's pushing to the Cosmos DB. So all your data is written in a transactional storage. This is an operational database, and it's saving the data as JSON by JSON. The main reason it does that, because usually your application, for example, if you are like an Amazon page and you are trying to, for example, get the product, you have the product ID, you send the product ID, and you get all the data you need to render that page. So usually you have the key, you get the value. It's much easier to find the data like that on the disk. This works great for the applications. But if you have data scientists, if you have analytics, if you need to get some reports from Cosmos DB, this doesn't really work, and it makes the database even more expensive if you're going to let those people to actually hit here. You don't, well, hopefully you don't do that in SQL Server, right? You have a different environment. You have, a reporting environment. You have a data warehouse somewhere. So you don't let data scientists go write this crazy query in here. Don't do that in Cosmos DB either. Cosmos DB is a transactional database. It's not a data warehouse. So to fix this problem, you can actually enable the Azure Snaps link of Cosmos DB. By default, this is not there, so you have to actually enable it manually. As soon as you do this, Cosmos DB is going to actually start to move your data from transactional storage to the analytical storage in itself. That means you don't need to write an ETL, because probably that's what you are doing right now for SQL Server. You have an ETL job, which is moving data from the operational database to reporting database. Maybe you have an analytic in our environment, so you move them manually by ETL. Cosmos DB is going to actually do it for you, so you don't need to worry about the ETLs. This is giving you a great isolation between environments. So in this case, our data scientist is going to actually pull the data from the analytical storage here by using the Snaps SQL or Snaps Spark. And this is going to be much cheaper to actually pull the data to, rather than pulling the data from the operational database. The data is actually getting saved here as column store, which means that in here, we save the data by JSON. In here, we are writing by property. So let's say our prop one, maybe the age of the person, and you want to get the average age. Well, guess what? All of those ages are going to be saved one by one after each other. And it's going to be much easier for Cosmos DB to actually find this data and give you the average. So it's going to be much easier, and it's going to be much cheaper to get it this way. So that's what calls column store, which we have in SQL Server too. All right, so next we are going to look at Cosmos DB, I guess, architecture. So Whenever you create the Cosmos DB's service, it's pretty easy. You just give a name for it. You pick a resource group, subscription. There's nothing really special out there. As soon as you have the service, you are ready to create the database. When you create the database, you have to give a name to the database. And the next thing you kind of need to, I guess, pick, which is very important, is how you are going to get data from this database. In T-SQL or on the SQL Server, you have one way. You must know T-SQL, and that's it. That's how you get the data. In Cosmos DB, you have options. So by default, I will suggest you pick the SQL. The main reason for that is SQL is the SQL language written for Cosmos DB is written by Microsoft. So most of the new features actually goes in SQL. And if you need any new features, Microsoft is in charge. They might be, help you with that. So if you're creating a whole new application, I suggest you to pick SQL API. But you have other options. So you have Mongo, you have Cassandra, you have Gremlin, and you have Table API of Azure. So if you have a Mongo application, let's say you have been, using it for 5 years or 3 years, whatever, you already have some kind of code out there which is pushing data to MongoDB, and you are tired of maybe maintaining your MongoDB database. What you can do here is you can actually push your data from the MongoDB to Cosmos DB, and all the APIs you have, which is pushing data to your MongoDB, all you have to do is change the connection string from MongoDB to Cosmos DB, and all your application will think that they are actually accessing the MongoDB when they are accessing the Cosmos DB. So usually you don't need to change that much code in your applications to be able to do that. That applies to Cassandra, Gremlin, and Table. So in that case, you can actually get or insert data in, I guess, different ways. Now, after you create any of those here, you are going to start to actually create container. Container is, I guess, equal to tables in SQL Server. So containers might name different depending which API you pick. For example, in SQL, it is called documents. If you pick Gremlin, you're going to have nodes and edges. If you're going to pick table, your container is going to have rows. So those are most important if you are especially using the REST API of database. And you need to know the URL, and URL the naming might be changing depending on the API. So each container is going to have a bunch of stuff here. The first one, we have the store procedures. So let's say our container named users, right? Your store procedure is going to have, or it can read or write only from the user's containers. It cannot reach to other containers. So everything you see here are specific to this container. The first thing you need to know about the store procedures, well, you need to know JavaScript to actually write store procedures. The second you need to know, if you actually remember the replica set I showed you, we had a leader and 3 followers. Store procedures always run in the leader. They will never run in the followers. That makes them actually a good fit for writing data, not reading data, because you don't want your leader to read data. You want it to, because getting all the updates, insert, delete, so it's always changing the data. So if you're writing a store procedure in Cosmos DB, be sure that you only write data in that store procedure, not read data. User-defined functions are just like store procedures. You need to know the JavaScript for them. Those are the great way to express complex business logic in a query. So you can use them for that. Just be sure that whatever you try to write here is not already there. So if there's a system, user-defined function, just use that rather than you try to, I guess, recreate another one. And also, you want to be sure that the whatever function you create, when you put that in your where clause, I hope you won't, but if you have to, if you're going to put that in where clause, just be sure that you still use the partition key or some other filters so we can actually hit the other indexes to get the data. If you are going to put the user-defined functions in the where clause itself, just like SQL Server, you're going to have a table scan. And that's not good. That's going to cost you a lot of money. and it's not gonna be easy. So just don't put that as a only, I guess, filter in where clause. Triggers, we have two types of triggers in Cosmos DB, which is the pre-transaction and post-transaction. And unlikely SQL Server, they don't get fired automatically. So you have to actually manually trigger them from the SDK if you want to. Merge procedures and conflicts, we just talked about that earlier. Those are the times that if this container is available in 2, 3, 4 regions, and if they are trying to insert or update or delete the same data, then that's how the conflict and merge procedures are going to actually handle those conflicts. So you actually create a store procedure, you register as a merge procedure, and whenever conflicts happen, you actually run this for each conflicts. Now, if we look at some of the, I guess, internals, when you look any kind of documents in Cosmos DB, you are going to see some really columns or the properties is going to be always there for any records. The first one is the underscore RID. That is the unique identifier of the item. This item can be a document, that can be a container, that can be a database. All of them is going to actually have the same properties. ETAG is mostly used for the optimistic concurrency control. So usually this is getting handled in the middle layer, which developers actually handles that. So if I try to explain that a little bit more, so let's say in SQL Server, we use the updated by, updated date, inserted by, inserted date. So what really is, I guess the developers use that for. So if 2 people is gonna, open the item at the same time, well, SQL Server doesn't know that, and SQL Server doesn't care about that, who's gonna write first. So developers actually has to kind of create some kind of logic in the middle. So if they're gonna try to, write the data, and if somebody actually writes the data before them, you want to actually send them some kind of notice, say that, what, you open this page, but somebody else already saved and changed this data. You should get the latest data and look at it and then save the data back. So they usually use that the updated date, updated by, or columns like that in SQL Server. So in here in Cosmos DB, we have the ETAG. Actually, what all you can do is you can actually pass this ETAG to your request, and Cosmos DB will actually automatically make that comparison. And if somebody already changed that, it will actually throw an error in the database level rather than you do that, I guess, try to handle in dev level. Underscore TS is a timestamp. Whoever changes the data, that's the last updated timestamp. And we have underscore self. This is really the pinpoint of your document. So if you look at it here, for example, we have self here. As I said before, you have the record ID for any type of objects. You have documents, you have databases, collections, anything. So in this case, our RID is the value here. So if you look at the self, this is a database. This is a databases RID, which is the record ID. This is the collections. This is the collections record ID. This is the documents. And as you can see, the documents record ID is this. So by knowing this, you are really pinpointing where this document is. This is mostly kind of useful, especially if you are using the REST API, because you kind of write URLs like that in REST API. And also, we have the ID. ID is the only, I guess, the property you can override here. You cannot update any of those here. Everything's auto-populated. But ID is the only one you can override. So in other case, if we have a table or the container name users, and you want to keep this ID as a user ID, you can actually do that, and user ID will get populated here rather than you, I guess, change anything in randomly. So you can do that. All right, next, here's our data centers, the one that actually I showed you in the beginning. And the yellow ones are the current ones, and the orange ones are the upcoming data centers. So whenever I talk about Cosmos DB, usually I give examples about, all of those big companies are using them, and, all the IoT devices they have all the ships and they have all the planes, or, whatever, which is great. Cosmos DB works for them great. But that doesn't mean that Cosmos DB doesn't work for, if you have a small business, or if you have, like something in the middle. For example, if you're a hospital, especially right now, hospitals are very busy. This is the last time you want to actually make probably a database upgrade in a hospital. So in cases like that, Cosmos DB is actually great options, things like that. For example, you don't have to be a big hospital. You can have maybe like a local hospital with some branches around you. Cosmos DB is great for you because if you need to scale up and scale down, you can do that very easily in Cosmos DB. Education is the other one. Like many people, students are actually working from home now, most of them. So, and also in education, there's kind of interesting, really interesting projects out there, the IoT and other stuff. They try to track the security, they track the students, teachers, all kind of information. So Cosmos DB is a great option for that too. Food service. We used to go to the restaurants and be able to eat inside, but now everything is outside. So if you think about it, your users are everywhere for the food service, and everybody wants to order something. And Cosmos DB is a great option for stuff like that. You don't have to be one big restaurant and all over the place. If you are like that, that's great. But if you're a small one, you can use Cosmos DB probably for free, because Cosmos DB has a free tier to up the, I think it's 425 gig right now. So you might be able to use Cosmos DB for free in cases like that. As I said before, there are many industries out there which can and will use the Cosmos DB, and everybody's looking for the same thing. If you think about it, you are looking for scalability. You might be a small company now, but you might be a global later, and you don't want to deal with all those, upgrades and other stuff. Cosmos DB, you don't need to worry about it that much. Availability, geo-distribution. Everybody worries about those things. So you don't really have to be, I guess, one of the top big companies to use Cosmos DB. And the other thing, many people actually comes up and says that to me, or I heard from many other customers. They are going to say that, are you sure you are going to actually save your data in JSON? Are you crazy? Well, you don't have to be crazy with JSON, right? Unstructured JSON is just fine. We survived with data models which has 20, 30, 40 data tables. You can be survived with JSON. There's absolutely nothing wrong with JSON. As I showed you before, you can have your operational database, which everything will be saved as JSON, which makes perfect sense for web application. And if you want to analyze the data, you can push the data to the new analytical storage, and that analytical storage actually saves the data more like the one that you want to actually see by rows and rows anyway. So you just need to make the mapping, and you can get your data and analyze data there if you like. So don't let people to scare you by this JSON thing. So I think that's all I have for you today. And please give some feedback. Let me know if I need to, if I can make this presentation better. I will appreciate it. And thank you for having me today. And yeah, let me know if you have any questions. I can try to answer them now, or if you want me to, if you have another questions later, please follow me from the LinkedIn or Twitter. I'll be happy to answer from there too. Thank you.
Well, we have now about 10 minutes left. If you have any questions, please note them down in the chat. Okay. There seem to be no questions. Just a note that Productive Edge is having a breakout session during the break time at 1:30 in US time. We'll also give away $100 Amazon gift cards. We'll say we will just wait for some more seconds for questions.
Sure. Yeah.
And if not, I would say we just have a break here so everybody can also lift their minds a bit and enjoy a bit, because this was a very nice talk, very wonderful. Thank you a lot. Hasan, very resourceful and a lot to learn, really. I learned a lot today. Thank you.
Yeah, no, thank you. Thank you for having me. Thank you for moderating the today's